Hello. Hi guys, good morning. Welcome back. In this video, we're on string compression 2. Oh god, it's a hard problem, but make sure that we will be going on to every step from very scratch, from the very normal time complexity which every other YouTube channel will teach you, to the more optimized one which you can find also on Leetcode, to the most optimized one which will be very hard for you to find and figure out to trace the entire path from the normal to more optimal to more optimal. Again, you will not be finding this on the entire YouTube. Like, I guess probably one or two, like probably Mazhar would bring, because he actually explains it deep, but apart from him I don't think so if you will get this entire deep explanation. So let's start off. What will happen in this question? It says that you have a string compression 2. It says that run length encoding is something defined as, if you have something as, let's say, AA, so you just write okay A and the frequency of A, so it is converted to A2 A, and after that the frequency of A. Let's say I have C, so again C and the frequency of C, C3. If I have just one character, let's say if it is just a A, then just write it as a and not as a A1, right? As a and not a A1. Cool. So that is one thing. Now my question says is that I am having a string S and an integer K. Okay, now I need to delete at most K characters. The operation which I can perform is deleting at most K characters, such that the run length encoding of S has the minimum length. Now, bhaiya, what it means? It means that if you had something as A, B, C, D, so run length encoding initially without doing anything would have been A3. I'll just do a smaller A3, B, C3 and D. It would have been like this. But if I just have operation of deleting 2, so what optimally, in the best case, what I will do is I'll just delete this B and this D. I'll get a A3, B, C3. So length has decreased to 4. That is the minimum length which you can achieve by removing 2 characters from it. Again, for this example, you will see that I have the run length encoding initially as A2, B2, A2, B2, A2. Now I can delete 2 characters, right? So I'll delete optimally, most optimal solution, I'll delete these 2 characters. I'll get a A2, A2. So will you say answer is 4? No. A2, A2, both are A. So actually, ultimately, the run length encoding of this A is actually A4. So answer is 2. Now, the obvious case which will come to your mind is, bhaiya, with this example, it is very obvious that I will try to for sure apply my greedy and will try to remove the ones having the least frequencies. Okay, apply greedy and let me know how will you get the answer. So with this, if you just try to go and apply greedy, what will happen? If let's say if I take this example, A, B, A. If you know that okay, frequency of B is less, you will apply greedy. Okay, you applied greedy, and by the normal greedy you will just get A2. Firstly, it was a wrong answer, which means ultimately even if you apply greedy, you will be ultimately hanging out with some numbers which ultimately you will have to concatenate in the end. And ultimately, okay, right now I removed 2 consecutive B's, but what if some other B is at some other place? So again, removing which B would be hard for you, and if you even remove it, concatenating which portions again will be hard for you, which means you will have to ultimately go and imagine, okay, which portion ultimately I would be concatenating in the end. That will be a scary part for you. And if I use something very special greedy, AI greedy, as in like I just mentioned my special greedy as AI greedy, because it's a scene of generative AI, so I'll get an A4. That is okay, that is obvious. But again, that AI greedy is, you have to build the greedy such that it is trying for some possibilities. Again, I'm not saying greedy is not possible, I'm saying it can be, but it should be very smart. It should not work. Now again, it's not the only case. Again, if I let's say have the same example as A, B, C, D, and if let's say K instead of 2, if it would have been 1, then B and D both have the frequency of 1. Which character will you remove, B or a D? That's again for you will just simply say, okay, bhaiya, I'll just try to remove B because I can see that the frequency from the left and right are more for B rather than D. So it will be much better that I remove a B. Let's say if these all C's would have been A. So you would have said, bhaiya, I can know that, okay, A frequency is more on the left and right of B, so I'll just try to remove B. But it is a smaller picture. What if the string becomes bigger? How many such cases will you handle? Again, how many such cases will you handle? AI greedy can handle that, but you don't have AI greedy, right? So you have normal greedy, which you are thinking of, which for sure will not work. So right now you have figured out that, okay, greedy will not work. Okay, let's come back and try to simply figure out all the cases. Again, we are not going on to greedy, we are just trying to figure out all the cases. Now just forget that, okay, greedy was even possible. Try for all the cases. When I say all the cases, we just simply mean recursion. So I just simply will try for all the cases. Again, when I say all the cases, I have the operation which I can perform is remove something or take something, right? So for this character, I know I have a limit of k, that is the limit of k which I can remove at max, but still I have the option, okay, I can remove something, I can take something. So what I'll do is, okay, I can either keep this A or I can delete this character A. So I can keep this character A or I can delete this character A. So I have two options. So with this one recursive thinking itself, you have got to know that, okay, you will have two options for every character. It is similar to a 0-1 knapsack problem, which is, okay, you can simply apply recursion, and then for sure you will know that recursion will fail because it will go and try for all the possibilities. Then you can easily go and apply a DP, as in you will just do in a 0-1 knapsack. So can we easily apply 0-1 knapsack? Okay, is it so easy that it's a hard problem? And people are just not explaining this hard problem. So like, how come such a hard problem that you're saying, okay, it's a simple 0-1 knapsack? Yeah, it is simple. It's just that you have to figure out some cases. Some cases make it hard. How? That, okay, if I just simply say go and delete it. Now what will happen is go and simply delete, which means I'll just simply delete this character. Again, you remember that I had k possible options, or basically k chances to delete k characters, right? So now if I delete this, I know that for sure my k will reduce and I will simply go on to my next character. So in a simple, if I am at I having my k options to delete, which as in k chances to delete, I'll simply go on to I plus 1, and as I deleted one character, so my k is also reduced by 1. So that is a simple DP state which we can have. Okay, that's obvious, that's very sure. But what about if I say you have to keep it? If I say you have to keep it, then the things become interesting, which means you will now keep this specific A. Okay, if you will keep this specific A, so shall I just simply mention, okay, if you keep this A, you want ultimately, remember your maqsad, please always remember maqsad kabhi nahi bholna hai. Remember your maqsad or your aim was to get the minimum length. So ultimately you have to keep track of the length itself, right? That was your ultimate aim. So I just went on and I just said, okay, I can move on to the next character, right? Simply, you might say, okay, bhaiya, just do simply I plus 1, your k will remain as it is. Okay, that is true, but what about your length? How your length will change? Will it increase? Will it remain constant? How will it change? That will be dependent upon, okay, if you're moving on to A, then it will be simply a A2, or basically if next A, then A3, A4. So if I had A2, A3, A4, you saw length remained constant. From A to A2, length increased, but from A2 to A3 to A4, length remained constant. So as you're moving forward, it can happen that length might increase or might remain constant. So it's a variable for you. And how it is dependent, as in like when to know that length is increasing or length is remaining constant. One thing is, you saw, okay, length is 8 from A to A2 to A3, A4, and then maybe A9, then A10. You saw A length is 1, A2 length is 2, A3 length is 2, A4 length is 2. As when I say length, I actually mean we have two characters. That's okay, length is 2. A9 length is 2, A10 length is 3. Okay, that is one case when length is increasing. But what if I had A, then I had a C, then I had a A, then I had a A? You saw, okay, if I had a A, length is 1. If I had a C, again length is still 1. Because for sure, okay, AC, as in like length of C is 1, so AC will have a length of 2. If I have again A, then the length is 3 now. So you saw, if I had a, okay, length is 1, right? In this case, length is 1, okay, great. I had a again, okay, length is 2. If I had a C here, length is 2, okay. If I had a again, here the length will be actually A3, which is actually length of 2. Here the length will still be ACA. So here the length will be 3. Here the length will be 2. Because it is converted. It got shrinked. and that shrinking makes a length change. So we got to know one thing, that if we are moving on to next character, our length will shrink or not will be depending upon if I'm encountering a character which is same as that of me, which is previous character. So if I'm at C, if I encountered a same character as in C previously, so I'll just shrink my length. Okay, my length will become a C2. So you will say, bhaiya, C2 length is not shrinking, but it will actually mean shrinking length means, okay, if you encountered, let's say A, so if I had a A like this, let's say I had a A previously, so it is A2. Ultimately, remember it in your mind, it's A2. If you encounter a new A, previous was also A, length was 2 of previous, so your length, instead of becoming, let's say the length was 2 earlier, instead of becoming a 3 as a length, it will actually shrink to A3, which means the length will remain still a 2 of length. We'll go into more deep on this, but just a crux that we need the previous character, because if I had a AAA, if I had a AAC, so length is 2, okay, length is 2, both have a length of 2. New character, if I encounter the previous character as same, so I'll just ask, bro, what was the previous length? Bro will say, my length was 2. Okay, bro, length was 2, I am also same, so again the length will still remain a 2, and this length 2 actually means a A2, right? So it will just say, okay, length was 2, I am 2, I am very good. And let's say, bhaiya, if the length increased to 3, as in 3 A's I have, still 3 A's will still be a A3, which means a length of 2. So a length is actually shrinked length and one is actual length. So I'll keep track the actual length. From the actual length, any day I can get the shrinked length. If I know I have A having 9, I have A frequency of 9, so I always know it is A9. So A9 is always a shrink length of 2. So I know, okay, if the length was 2 previously, or let's say for your simplicity, length was 3 previously, and I'll shrink it, I'll get a A2, which is actually a length of 2. If I add a new A, I know the new length is 4. Again, the shrink length will still be a 2. So with this, and for sure, if you had a new character AAA, you had a 3. Previous length was 3. Shrink length was 2, but you added a new character, so new length will become a 4 and the shrink length will be 2 plus 1 because of new character. So that is how your previous character would be important. It's just for you to mention that, okay, last character also matters to us, just to know the new length. And also it's not about the only last character, as I also mentioned, it is also impacted by how many characters you had of the same character. So if I had a AA, so from A, let's say if earlier I had only one A, but I encountered one more A, so I'll get a A2. So length from A increased to A2, length shrink the length from 1, it came to 2. Again, if I had previously 9 A's and encounter a one more A, so from A9 it will become a A10. So actual length, which I want to have in my answer, because answer is of shrinked length, right? So it will increase to A3. Again, if I had 99 A's previously, I encounter one more A, then from A99 it will increase to A100. So this shrink length also increased from 3 to 4. So in all these 3 cases, again, in only these 3 cases, my shrink length will increase. So I know that my last character count, okay, what was my last character? It was A, but its count, okay, earlier I saw that the last character was important. Now I am seeing that the last character count is also important. So I am also saying that last character count is also important, just so that if I want to keep this. Again, if I had a A2, so you saw one more A came, it became a A3, okay, it became a A4, A4, it became a A5. You saw in all these cases my shrink length remained same. So again, in the remaining cases, apart from these cases, in all the other remaining cases, I don't need to monitor, because my shrink length will remain same. Right? Okay, cool. So I just got to know that, okay, I just have to consider these 3 cases only to just get to know, okay, if my shrink length is increasing or not. Or the other name for this shrink length in this question is nothing but our run length encoding. So our run length encoding, which is, I'll say, as a shrink length. So this shrink length should actually increase in just these 3 cases. Okay. So coming on back to our actual question, if we are keeping that character. If I keep that character, so I got to know that I just have to monitor. If that character is equal to my last character, then I will have to do something. So one thing is obvious, as we already saw, I plus 1, k will remain constant, but you will also have to pass in for your next character, which means for the next character, you will have to pass in your previous character, right? So for the next character, as I move on, okay, let's say I process this I. As I move on to my next character, so I will be keeping this as my previous character for the next index. So in my next function call, which is I plus 1, I am passing this s of I as the previous character. So obviously the last character, because you remember I have to get the last character. I have to compare that with the last character. So I need to have the last character with me. Okay, last character was there. And also you saw that if the current character is equal to my last character, so for sure the last character count has increased by 1. Okay, last character count has increased by 1. But you saw this is the simple recursive call, which means solve function. Solve function is nothing but a recursive call which you have in the top. Is this the length? It will not give you the length. Length either can be given by the base cases, which you will see later on, or else, you know, okay, if you are encountering the same character, so shall I increase the length or not? That is an option. If I encountering the same character, shall I increase the length or not? So you will increase the length only and only when you have these three cases. When the last character count is 1, 9 or 99, as I showed you, your length will increase in only these three cases. When the last character count is either 1 or 9 or 99, only then your length is increased just by one character, just by one length, just by one stringed length, your length will increase. So I got to know that, okay, my stringed length will increase only and only when my last character count is either a 1, 99 or 90 or 9 or 99. It will only increase by 1. And also thus I have to maintain my last character count. And again, it will only and only increase when I have the same as the last character. So okay, it is one case when I have my last character as same as that of current character, but it can also be different, right? So both the cases, if else condition, if it is different as that of the last character, then simply again same recursive call, I plus 1 k is just that, okay, last character also for the next, which means for the I plus 1, s of I will be the last character. Last character count as you saw, it was different. It was s of I was not equal to last character. So now my new character sequence has started. So just reset that to 1. So I just did a reset that to 1. Again, you will see that you can simply add a 1, because again, for sure, new character is added, which means that, okay, here I said, okay, a to, as in you had a 1a previously, you encountered one more a, so from a it increased to a2. Okay, for that you added a 1 in the if condition. In if condition, you added a 1 just because from a to a2 it increased. But I am saying, what about you had empty and you encountered first a for the first time, which means from empty to a, it is also one character counted, right? So for this condition, it is simple that, okay, you encountered the character for the first time, so simply add a 1 for that. And on it going forward basis, okay, if you encounter one more character, then from a it will become a a2, so add a 1 in the if condition. Again, these if else condition you can modify according to yourself. It's just that it's the most simplest thing which you can do. Again, a small recap that, okay, if you have same as a last character, simply you just increase the last character count and also add a 1 corresponding if the last character count is either a 1, 9 or 99. And again, if you had the new character found, which means it is not equal to your last character, simply add a 1 because you have encountered a new character. You will have a new beginning of life. Cool. So with this, you can simply get this solved. Again, your DP state will look like as I, K, S of I, which is the last character, which means for sure last character can only be alphabets. Alphabets are just 27. And also the last character count. Last character count, how many such alphabets can be there, as in the count of elements. It is just that, okay, if my string is of length n, I can have n characters at max, so the count also can be n. So This I is nothing but iterating on my string entirely. N, K is nothing but your K itself in the question. S of I is just the characters, so it can be just 26 characters, and also the count of characters, you can have all A's. So the worst case, the count can be all A's, which means all N characters are the same character, so I can have the count as also N. So your DP state will look something like this. Let's see the code very quickly. It's very easy, exactly as what I mentioned in the beginning also. Firstly, as we saw, we have a DP state for your I. It is for your last character. It is for your N, and it is for your this last character count, and this is for your K, because you saw K is also less than equal to N, so K can also touch N, and N is less than equal to 100. By the constraints, N is less than equal to 100, so for sure we have just put in these conditions as for N and K. Now coming on back, we will simply memset our DP. We will start off from the index 0. Initially, for the index 0, no one is the last character, so I gave a character value as Z plus 1, because A to Z are the characters, right? So Z plus 1 is not a valid character, so for the first index I passed a non-valid character, right? Okay, and then again, so far the count of last character count is 0, because there's no last character, right? And K's I pass in as it is. Again, because of this Z plus 1, I had to pass in a 27 and not a 26. Although we use A to Z are actually 0 to 25, same 26 characters, so this 26 would have been sufficient, but as in here I passed in a Z plus 1, thus I just passed in a 27 here, right? Okay, cool, that's it. Now coming on back to the actual condition. Now I had just K options to delete the characters, right? If my K becomes less than 0, so for sure return a very maximum value. Why maximum value? Because ultimately in my answer I have to return the minimum length, so thus I return the maximum value. And the other base cases, okay, if my index reaches the end, which means I have very peacefully completed the entire thing. I have whatsoever I had to remove, I had removed, and I can simply return a 0, because whatsoever I want to remove, I had removed. And bhaiya, but we wanted the length, right? So length as in the length amount. Yeah, length amount you are already adding in your if conditions. You are adding that in your if conditions. So don't worry, don't add anything extra. If you complete, just simply return a 0. Okay, cool. That is simple base case. Memoization, simple memoization. I just simply go and check for my current ith index for that last character count and K. If that is present, I just simply pass by address, so that I don't have to write the entire thing again and again. If that is passed by address, as in if that is there, so simply return a. If that is like, if it is not equal to -1, because the by default value is -1, if that is not equal to -1, simply return the answer. But if not, then memoization will not help, as in like memoization, it will go after, as in it will go in the recursive call. Recursive call, you have simple two conditions: keep or delete that character. If you delete that character, simply go on to the next character. These things will no matter impact, it's just that your K will decrease, right? We saw that if you delete the character, only these two are things which are actually impactful to us. But what if we keep the character? In keep the character, we saw we have two cases: if condition and else condition. In if condition, if my current character as of index, if it is equal to my last character, then I have to do one thing, that I'll go to my next character. I'll also go and keep my K as same. It's just that for my last character, I can either put a s of I dx, or I can also place a last character. Both are equal, because see, both are equal, so I can place anything here. That's true. Okay, that is true. In the last character count, I'll increase a 1, because it is again the s of I is ith index character. It is same as the last character, so your last character count is also increased by 1, because it is the same character, right? So increase by 1. It's just that these three condition, if your last character count was either a 1 or a 9 or a 99, then increase your length by 1. So this possible lengths are just saying, if my length is either a 1, 99 or 99, then you just increase your length by 1, else by 0. Else your length will not increase. Now coming on to the else condition. Else means, okay, the current index is not equal to your last character, as in AAC. So you are at C, it is not equal to last character. So in that simple case, again, you go on to the next character. you go and keep your case same. It's just that your last character will become s of I index, which is for the next I plus 1th index. Last character is s of I index, right? And also you have your new last character count as 1, because for this I plus 1th index, it is the first time s of I index is occurring, so its count is 1, right? Okay, and 1 because for sure you are starting off your character as a fresh character. Again, if I go back, for these 3 cases, it is covered in the if condition. For this one case, it is covered in the else condition. And with this, you can simply get this solved in O of n into 26 into n into k, and n space is also same. Now this is the solution which you will find on the entire YouTube and stuff, and also on the topmost solution of Leetcode. But again, this is not the optimal solution. Now we will go and optimize it. How? If we go and look for clearly that firstly the space and time, although both will pass, again this entire thing you can go and check the solution itself. Here's the link, you can go and check. It will pass, for sure it will pass. It's just that it is way too much hefty in time and space both. Can we optimize it? Yeah, we can. How? If we go back and look carefully what every piece of information was saying to us. N was for the index, which will I have to go for sure. This is for the last character, what all last character I had. This is for the last character count, what all character count I had encountered so far, right? Whichever character I had, what is the count for the characters I had encountered so far, and this is a k, which will also remain there. So I know that okay, n will remain, k will remain. Maybe can I do something, because this is a thing which I have added, right? You saw in delete I was only requiring n into k, but because of keep, which means because of keeping the character, I had to use this entire stuff. So can I optimize this? Maybe I can, maybe I cannot. Let's see how it will look like. It is last character and its count. So I am saying right now that last character and its count, although you are saying it is 26 into n as the all possible options, but I am saying in the worst case, you will have only n possible combinations for this. Right now you are saying it can have 26 into n options, possible combinations. That's the reason you made the entire thing as 26 into n, but I'm saying in the worst case it will be n possible options. How? If I had the character as, let's say, one example, if I take a, so again the combinations it can form as a1, a2, a3, a4, character and its count. If I had a AACD, it will have a a1, a2, c1, d1. You saw A, C, C, A1, A2, C1, C, D1. So you saw it is just 4 times. So thus this combination will occur just n times itself. So rather than saying it is 26 into n, I can easily say it is actually just n. So instead of having this 26 into n, I convert this to a O of n. But because of this, I cannot statically assign memory, because I never know that okay, if it will be a C1 or a C1, I will have to like if I statically, because in the above example you will see I statically assign memory, but here I cannot assign statically memory because I never know if I encounter a C or a Z, right? Because if I encounter a C, right, so if I keep the memory as 3, so I can have the index as 0, 1 and 2, so that will work. If I encounter a Z, so I will have to keep the memory as 0, 1, 2 up to 26 to actually encounter that 25th index. So I cannot keep the static memory. I have to go and use unordered map or something as unordered set so as to keep track of it. So what I will do is, I know that okay, my time capacity actually has reduced to O of n into n into k, but then I have to hash, because for sure I will have to use dp, but then for the memorization part I cannot statically assign memory. So one way is to just convert this entire thing to a hash and then use that hash to just say okay, that my dp of this hash, I just do okay, if this is not equal to my dp dot end, which means I have found it, else I have not found it, I will go into recursion. So rather than if we go on the top, rather than checking the actual dp state, I'll convert this entire dp state to a hash, and I know that this hash will occur only O of n into k times. right? Because this 26 into n is converted to O of n in itself. So I know that this hash will have O of n into k different values at max, right? So what I'll do is I'll just go and convert this value into a hash. Ultimately, you saw that I had a IDX, I had the last character, I had the last character count, and I had k. I know that, okay, these are the values. Early, as also, if you remember, it had 100 as the maximum possible length, it had 26 as the maximum possible length, it had 100 as maximum possible length, it also had 100. So I just had to convert that to a hash simply. Okay, do a k plus, you don't want to overlap these values. So if you convert that to a hash and you don't want overlaps, so next values multiplied by 100. Okay, next values, which is last character count multiplied by 100, right? And for sure it is 101 because you will actually have one more extra thing. So it is 101, it is 27, it is 101, it is 101. So I'll just do 101 plus for the next thing, which is the last character. Again, simple, last character multiplied by this two values, so as to shift that to more right. Okay, so last character multiplied by 101 multiplied by 101 plus this index multiplied by these last three values, which is these three values, which is index into 27 into 101 into 101. So this will give me a hash. This will give me a hash for this entire DP state. So as you will see here, again I converted this entire state to a hash, and this is the key. Key is nothing but the exact same thing which I showed you above also. Now I'll just simply use an unordered map, right? Because I know that this DP state, this key, or basically this hash, will have only distinct n into k different values. So I just converted that and used that in this DP itself. And again, ultimately you will see that the exact same thing is done here. It's just that I'm using a DP. That's it. Nothing else. I just removed the condition memoization from here. Everything is exactly same. It's just that I converted the actual things into a hash, because I know that this hash will have n into k distinct values. So because of this, my DP memoization and also time have reduced to O of n into k. Again, I'm not saying 26 into n into k. I'm not saying I removed the constant. I'm not saying that. I'm saying this 26 into n itself is actually O of n itself. Cool. Okay, now this portion is done. And for the people who use Python, for them memoization internally, they don't have to statically define this, so for them it will actually work. Now coming on to the better, most optimal part. Now if you remember in the beginning, I told you that greedy might work, but again you will have to do AI greedy. What does AI do? AI does what? Like, how does a chess AI works? He tries for all possible combinations very fast. That is what we will do. We will we will use greedy, but we will still try for all possible combinations. And that is where the DP will also come in, because if you try for all possible combinations, it's recursion. But recursion, if we memorize that, it's a DP. So we will use recursion, we will memorize that, but we'll still use greedy just to get the answer. How? What we will do? If we are at a random index I, so I'll try on for all possible combinations, which means I'll try on for B, BA, BAA, BAAB, BABB, which is this length, this length, this length, this length, this length, and this length. I'll try for all possible lengths. Now I'm just going forward, right? In this length, what I'll say is, okay, I'll try to form a group. Now what I mean by group is everything inside a group will have the same character. So if I am saying, okay, it's a BAA, so ultimately my aim is to form a one group. One group as in it should have only one character. It should have only one character, so I should remove some characters. So if you have a BAA, I ask you, you have to remove character. So you will for sure say, bhaiya, remove a B, because then you will get a AA. Or like if you had removed the A, then you have to remove two A's, which is more costly, because your K is the cost, which means K is the something which you will spend very dhyan se. So you will remove your B itself. So here is, okay, you are trying for all possible patterns. You will, which means starting from I, you are trying for all possible things. And also in that all possible things, it's just that when you know that, okay, you will make a group, and for that group you need all elements to be same. For that you will remove some elements. Now to remove some elements, you will just remove the elements which are having the, like, you will keep the one having the most frequency and you will remove everything else. So again, if let's say I give you this example, BAABB, now for sure my I is here, which means my I is here, and then as I showed you, I'll try for all possible J's, which means my J is here, then my J is here, then then my J is here, and so on and so forth. As you can see, I'll try for all possible J's up till the end. So for any random J, let's say I pick this example, I want to form a group. My group is nothing but all the elements having the same frequency, like all the elements which are the same characters. So I know that I have to remove everyone else. If I go and ask you what is this range length, if I have this I have this J, so range length is J minus I plus 1. Okay, the range length is this. If I say you have to greedily take the one having the maximum frequency, right? So you will take the one having the maximum frequency. Maximum frequency is from B itself. So you will take the one having the maximum frequency. So you took, okay, 3 I took. So what all you have to remove, the characters which you have to remove is, okay, the entire length. It is this entire length, maximum, like range length. You will remove everything else apart from this maximum frequency. So the things which you have to remove is this range length minus 3. So this range length is actually 5, minus 3 will give you 2. So you will remove 2 elements, which is these 2 elements. These 2 elements you will remove, this A and this A. So the number of characters to remove are actually J minus I plus 1, which is this range length, minus maximum frequency of the element, which is the maximum frequency, and you will just remove these many characters. Again, these many characters which you remove are in the limit, it should be in the limit of K, because K is the actual luxury or the number of characters which you can remove in the total. So please make sure that this number of characters you remove should be in the limit of K itself. Okay, great. Now if we go back, as I was trying from the starting from I am going and try for all the substrings and making a group. So, and I also mentioned that to make a group I have to keep up the same elements. Now bhaiya, why not take the maximum as in you took was BBB? So why you are taking and grabbing this again and again? So it's just simple that in this all the substrings which are formed, again I said I'll try for all the substrings starting from that index I. So you saw one of the possible cases here are BAA, other possible case was BABB, right? So BAA, if I remove a B, it will form a A2, like AA, which is actually a A2. But in this case, if I removed a BAABB, then I got a BBB, which is actually a B3. So again, this makes sure, okay, I'm trying for all possible combinations, but to actually convert this to this, I'm just trying, okay, remove the ones having, like, only have the ones which are having maximum frequency, remove everything else. So with this fact, what will happen is I will have my index, I will have my K. As simple as that. It's just that I told you, we'll go on to this condition later on. It's just that I'm showing and the code itself, the logic. From that index I'll go on to all the other indexes. Starting from that index, as I showed you here also, I'll go on to all the other indexes. Starting from that index. So J is nothing but all the other indexes. Now if I go on to, I'll just have to minimize my length. My length will be minimized by, okay, if I just take that group starting from my IDX, if I just have starting from my IDX, so IDX to the length of J, right? Grab this frequency, whatsoever frequency you have, convert that frequency to length. Now here, what you mean by convert to frequency to length, we'll see. But if you convert that frequency to length, okay, it will be added to your length, and then you will just simply call the recursive function to J plus 1 again. Starting, because you know that, okay, I to J is already made a group and converted. Now you will call from J plus 1 up till the end, right? So you call from J plus 1, your K will actually be reduced by number of characters you removed in this entire range. And as I showed you, in this entire range, the number of characters I removed are actually J plus 1, J minus 1, J minus I plus 1 minus this maximum frequency. I just wrote the same thing as number of characters to remove is the entire thing which I will put in here, right? So with this, I'll just say, okay, I to J, I'm trying to make everything as same, and then I'll just start and call my actual recursive call starting from J plus 1 itself. And to convert this, which means to convert this, the cost required, I am just using greedy, which means I just try to take everything having the maximum frequency and will remove everything else, so as to achieve the minimum K reduction, because my K is ledger thing which I have right now with me. Again, if I just achieve this, okay, idx to j, I get it everything of the same frequency. So convert this frequency to length, because ultimately you want to shrink the length. You have the frequency, but you wanted to shrink the length. So if you have a frequency as 1, so it will look something like just a, so length is 1 itself. Okay, frequency to length converted. If I have the frequency as 2, a, it will become a length of 2, a2, right? If I have frequency of 3, which is a, it will become a length of 2 again, which is a3. If I had a frequency of 10 of a itself, which is a 10 times, then I will have a length of 3, which is actually a10. So it's a reason you have to convert your frequency to length to actually get the actual shrinked length, because answer is nothing but your shrinked length ultimately you want to return in your answer. But bhaiya, how to get this frequency and stuff, we will see. It's just one line code above which we actually keep on maintaining to get the answer. Now coming on to base case. This base case, as you saw earlier also, if k reaches beyond less than 0, which means I have spent money more than my pocket, okay, which means so simply return infinity, because in real life it's not possible. And also if you have reached the very end, then simply return a 0, or also a small condition. Again, it is optional for you to add. It's just that it will just be much more, like it will not go much inside the recursion tree. It's just that you can return easily if your n minus index is less than or equal to k. What this means is, if your index is at this location, your n is 5, so you can for sure know that you can for sure delete these 3 values in the end, right? You can for sure delete. So I know that n minus index is nothing but these 3, number is 3, so I can remove these 3 values. K is 4, I have options to remove. I only want to remove 3, I can simply remove 3, because my n minus idx, which is 3, is less than or equal to my k, so I can for sure remove it, because k is the actual bank balance which I have, and this is the amount of kharcha which I have to do. Cool. So this is the entire code which you will see. Again, you might be still confused, bhaiya, what this maximum frequency length. We'll just simply have this one line in code which will solve it. So if we just go back, now we only need my n and k, because starting from every index I'm trying on for all the sub arrays starting from the index I. So I just simply start off from my index I with the k as my budget. Now these two base cases, as I explained, exactly same. A simple memorization, as I explained, exactly same. Now comes the simple part. You remembered I told you for that group from I to j, I wanted the element having the maximum frequency, because that element having the maximum frequency will be the final one in the group. If I had a b, a, b, b, right, this was the one. So you remember that ultimately I will be thinking in my mind, okay, I'll convert this to a b, 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 greedily taking the one having the maximum frequency. So ultimately, you know, the frequency, maximum frequency will become a 3. So this maximum frequency is this maximum frequency, I convert that to a length. So I just use this entire thing to convert that to a length. So one thing is, I have to find the maximum frequency. Simply do here also a bit optimization is there, that you are starting from the index I. Now for every j, which means j is here, so I'll just put it as b, a, b, b. So your I is here. Now initially your j is here, now your j is here, now your j is here, now your j is here. So you just keep, as you keep on moving your j, you also keep on getting your maximum frequency. As you will just simply keep an hash, you will just simply keep a hash map, or basically you can also define the static thing. It's much more like lesser in time for C++ and Java, but in Python you can just define a hash map of stuff. This will actually make sure, okay, you are just monitoring the frequency of the characters. So you are updating your maximum frequencies at every point of time. So if you just iterate on, if your j is in the beginning, your b frequency is 1, so maximum frequency is also 1. Here the a frequency is 1, maximum frequency is also 1. Here the a frequency will become 2, maximum frequency will become 2. Here the b frequency will become 2, so maximum frequency will still remain 2. Here the b frequency will become 3, maximum frequency will become 3. So you saw that maximum frequencies keep on updating at every index as we are going on, which means j. And as you know that I have to convert my max frequency to actual length, because in my answer I have to add the length and not the frequency. And this is the exact same, j plus 1, because I did for I to j. Then go and simply go and find for j plus 1 as simple recursion. Again, k is the option which I had. This value is as I showed you in the beginning, that number of characters I have to remove, and this is the facility or the bank balance of me to remove. I can simply do that and ultimately return that in my answer. To convert this to a length to maximum frequencies, just a if condition. If the length is 1, you just require, if basically if you have 1a, so it's a, right? If the length is less than 100, which means from 2 to 9, it's a a2, length is 2, right? If the length is less than 100, which means a10 to a99, so it's a length of 3, as you can see, length of 3, and else the length of 4, which will never occur for sure, because you saw that you have only 100 characters. So it can occur if all these are same, which means a up till a 100 times, so it can be a 100, but yeah, that is the only thing which you have for 4. So again, this will convert my frequency to the length required, and again I can simply return that to my answer. Again, this is the addressed value, so I don't have to pass in my dp, it's address, so by default it will go and put inside my dp values. And this is the simple initialization and simple of n, and again calling my index and my k, and that's how you can simply solve this in O of n into k, which is the dp state, as you saw, n k, and for sure you're going on to all the states, which means starting from index I, you're going on to all the j's, right? All the j's. So for it is for all the j's, but the space is actually reduced to O of n into k, and that's how you can simply reduce that. Again, this video is 45 minutes long, but I wanted to go in deep on all the approaches from very scratch to the entire thing. As you can see, this was the entire notes for it. Cool. So we discussed the every approach for it, starting from this to this to this. I hope that you guys got it. See you again. Bye bye. It was a long video, very long video. Pasina.